Hi, thanks for joining in. Today I have fresh directly from the factory to the workbench the brand new FNIRSI DSO-TC3. I was quite expectant regarding this device. The users of the DSO-TC2 and the viewers of the channel were quite critical regarding the lack of some features like the ESR value on capacitor testing. Spoiler alert, this new device seems to have solved that issue, but added a lot of improvements to the previous version, like more bandwidth support on the oscilloscope or a new graphical UI. For disclosure, this item was sent by FNIRSI for review with no costs for me, and I don't receive any payment for making this review. Even so, I should thank FNIRSI for sending this item free of charge, but also my viewers that through the channel affiliate links on the screen and also the product affiliate link in the description have been helping me to support the channel. When you use these links before paying and for a short period, I receive a small commission for your purchases on AliExpress and Amazon. So thank you so much for sponsoring the channel even without paying a cent more in your purchases. Can't wait any longer. So let's get this party started. Okay, as usual, let's start by seeing what is delivered in the box. I already opened to speed up the things. We have, first of all, just one probe. I think it's the 6100, it seems to be, it's the normal one. Yeah, 6100. Ooh, we have stuff for other review. Let's keep this away. And yeah, let's take this out of the box. Okay, so this seems very well packed. As usual, they change, as I talked before several times, the packaging. Let me take the plastic off. Okay, so this is that kind of box that has some reflection in the device. It gives a very nice effect. So let's start by seeing what we have in the back. Okay, so what we have here, we have transistor tester function, function signal generator with 6 kinds of signal waveforms, digital oscilloscope with 500 kHz bandwidth and 10 megasamples per second of sampling rate. Yeah. Full trigger function, single normal auto, and a lot of stuff to test. I will not even try to show you what is included in this. So this is the box. Let's open it. Let's see what we have here. Okay, so we have a box with products. I think it says download manuals and firmware. You have here the quick link. So inside we have a USB Type A to Type C charging cable, the normal cables with a hook in the end to test. So in here we have a alligator to MCX connector, is this little one. We have a user manual. It seems to get better. It's larger, different finishing, very nice. English, Chinese, Russian, and Portuguese. Yeah. Okay, so let's see in English because it's the most spoken language. Yeah, so we have in here, let me see if I can take out the bright of the paper. 2.4-inch TFT color screen with LED backlight, rechargeable battery, USB type, yeah, the normal stuff. The technical characteristics or details of the oscilloscope, and in this side we have the tester and what kind of components can be tested. And the NAC protocol in infrared remote decoding. It's not all protocols, it's just the NAC protocol. You have also the function generator in here. Yeah. So, very well done, as it starts to be the norm in FNIRSI. I'm very happy with this kind of manual. And yeah, everything in here. And we have also Portuguese, that is very good for me. Okay, so we have a very nice card here with some kind of warning. Okay, nothing special, but you should read this carefully. The key A, and finally we have the device. Let's open it and see the first impressions on this device. So the first impressions, it seems to be very equal to the TC2. Let me just put it side by side. Yeah, the device, it's almost equal. I will say we have here something that seems to be a reset button. Yeah, in first impressions it seems to be very similar. The plastic, yeah, even the plastic, it's the same. Let's see if we have power in this. Oh, the screen has a different Y, very different, 4 pages, as you can see. Let's see if my previous one, yeah, as you can see in this one you have only 2, MOS and oscilloscope. Let's go to MOS test. Okay, this one has oscilloscope, generator, tools, and tester. Let's start with the tester. Okay, in terms of graphics they are much better, as you can see, totally much better. Let me see if I have, I think yeah, my 650 kilo ohms resistor, just to test. I will test everything after, but just to see right now. Oops, let me open the gate. Yeah, and let's do a test run. No, okay, testing. 675 kilo ohms. Let's see what we have in here. Okay, the keyboard 75 to 77 in this one. Let's test again. 78. Yeah, this one, it seems to have different functions, the buttons. Okay, menu, auto. Okay, run, and here we have test hold, and this one just has hold. So we have different changes. One thing that is awesome, I don't know if the battery is very low because I don't see any green in there, is that you have the battery indicator there. That is very appreciated, really. Thanks, FNIRSI. So let's see what else we have in here. This is just first impressions. We still have this 90-degree angle stand. Let's go back and the power button, now it's also the back button. We have the oscilloscope. Okay, I will show you in a bit how all these functions working. Probably we'll need to power this up. Let me see if I have here my cable. Sorry for the noise. Yeah. Okay, it's charging. You have a light here while it charges, yeah, but no indication on the battery icon. Let me just go back and try again. Yeah, no indication there of what is happening. I think I remember, yeah, we have, I didn't show this before, but you have an adapter for MCX to BNC to connect here also. I just look at him and remember. In terms of interface, the graphics seems much better also in this screen. Let's move this to oscilloscope. As you can see, let me take this out. The graphics in here, oops, I made a mistake. Seems much more organized. This one seems a little basic. Even if the information is the same, it seems to be more organized than this one. So quite an improvement also in the screen. Let me hold a bit. Yeah, the information goes out like this. It's the same. We can, let me see, where is the cursor? This is the auto. We can change the cursor in here. As you can see, it's moving in a counterclockwise way. Yeah. So I will show you this more in a bit. Let's move on to see what else. We have the generator also. Okay, seems good. And the tools. That's more or less the same we had in here. So tongued one, I don't know what is tongued one. We have voltage, DSO, and calibration also in here. To the left or to the right, it doesn't do anything. So let's charge this thing up and let's see what we can do with this. What are the main difference from the TC2? Okay, let's start by peeling the plastic out. Very nice. Okay, that's it. So right now I will power this on and let's start by seeing the menu system. This is a huge difference from the previous version where you have only two options, to mouse test and oscilloscope, and you can choose like this. In this one you have a menu system with 4 options and some very nice icons. So yeah, you can choose from any one of them. I will start with the first option. It's the multi-mode tester or whatever, or mouse tester. So let's start by seeing the OK to enter. As you can see, it is very similar in terms of the design, but this one, oops, OK is here and this one was here. But as you can see, the graphics are, for me at least, a little bit better. Okay, so what do we have here to test? I'm gonna start by testing some LEDs. This is typical. Okay, I'm gonna try not to spend too much time with this. Okay, it's not run. You should press OK. So this one has 2.55 volts. It considers a diode, but it's not working properly. Let me see, like this. Now the light appeared. Okay, it says again it's 2.55 and you have a new item that is IR3NA. Okay, let's try. I have this one. It's a welder module. Let's see what we get with this. Okay, 1.91 volts. Very nice. Let's move on to, let me try also to see if this is infrared. So it should not work, but yeah, it detects as a diode. Let me change. Yeah, so this is a infrared diode. The normal resistor. Let's see what we have with resistors. Okay, we don't have anything because I didn't put this. So let's see what we have with resistors. No, not good. Like this. So we have here, I believe, 1 mega ohm resistor, something like that. And this one should be, I think, 680k. Let's confirm. Yeah, let's try again. Okay. So we have also here to test some capacitors. Okay. Let's see. It's taking a little more to test. This one is 9968 nanofarads. Okay. With a veloc of 0.0 with a veloc of 0.2% and ASR of 0.33 ohms, and this one was missing on this device, and you have it here. Okay, so let's try another one. Again, I will try not to take too much time in this because it's quite time consuming. Let's do like this. Yeah, we have another capacitor. I think it's not well connected. Let's try. Yeah, now it is. Capacitor takes a little more. We have 978.8 nanofarads, veloc of 1.0 and ESR of 0.77 ohms. So yeah, it works pretty well. I have here also a transistor. Let's see. We have a transistor, PNP. It has HFE 117, VBE 0.61V, and IC 1.0 milliamps. So very nice. Let's try another one that I have here. Let's see what we get. So this is also a transistor, NPN, and we have HFE 270, VBA 0.71 volts, and IC 7.4 milliamps, I think. Yeah. And we have also like diodes. I think it's okay. No. We have a diode. Let's try again. Okay, now we have it. VF 0.24 volts. Capacitance 43 picofarads, and IR is 0.7 microamps. So this is it. And for last, I think I have here a Zener diode. Yeah. So for this one we have 0.7 volts. One thing that is really different from the old one is let's select testing, and where is it? It's like pressing menu for a while. You will have this menu, and let me try to, for testing Zener diodes, you will have here the option number 4. It doesn't make much sense to have this in here. They brought it back to the normal testing system, and that is quite a plus. Okay, so moving on, I will take this out, and for last, let me try one last thing, that is a inductor. So for that I have here this one. Let's see what we got. It detects inductor and it says it's 0.08 millihenries. So what we have here, 100 millihenries. No, 100 microhenries. So yeah, should be okay. Almost there. With a resistance of 3.1 ohms. Very nice. Okay, I think for component tester we have it tested. Let's move on to the second option. So the next thing to test is the oscilloscope. I have my signal generator already creating a signal for this. Right now it's 50 Hertz. Let me try do auto again. Yep. Okay, let's increase this to 100 kilohertz. Auto again. Yeah, still good. 250 kilohertz. Again, auto. Still good. And let's see. Yeah, the frequency is set in here. We can see in this line the frequency. VPP 9.2. This is a bit weird because the VPP it's 1 volt. Maybe the signal here needs to be 1 time. Let's change that. Okay, this now it's more according to the reality. It's 0.93. So according to the normal math, this should be over 0.7, 14 to 20, 700 millivolts. Let's move this to 500 kilohertz. It's the maximum. And yeah, in there we have 0.81. So 500 kilohertz, still good. Let's increase here the time. No, no, this is the minimum time that we can have. It's 1 microsecond. Yeah, so the signal in the maximum is 500 kilohertz, and we will have a VPP over 0.7 volts or 700 millivolts to be more precise. Let's move on this to see where it will start to fail, and it's yeah, so the maximum that we can have it with the signal at 700 millivolts, 740, 50. This is 600 kilohertz. I think that we can make it go to to 650. So this is the maximum that we can have the signal to maintain the voltage over 714 to 20 millivolts. So pretty nice. We have a safety margin here, and that is awesome to know. Okay, this is 500 kilohertz again. The bandwidth, it's not very high, but for students and even professionals that don't need a very high bandwidth, it should be okay. Let's see what else we can do with this. Let's move the cursor on. With this you can move up and down the offset like this. It's pretty slow, but yeah, it's going there. As you can see, it's on blue right now. If you move to the right or the left, you can move the cursor, this selecting cursor, this blue one. You can change, you up and down change the option. You can change, for example, the vertical resolution like this. It's the amplitude of the signal or voltage. Also, you can change the 1 time or 10 times. This right now it's outputting in at 1 time. The time division, horizontal division, okay, increase or decrease. And let me put this like 100 kilohertz. It will give me a better signal to show you. Yeah, and let's take this again. Okay, as you can see, the time division and also the coupling. I don't know, it was in AC. Let me change it to DC. As you can see, it changes the offset a bit. This one is just an indicator. You cannot select it from the menu. You have also here the battery indicator. Right now it's 2/3, I think, or no, a quarter. It's already used. We have also the edge, rising edge or falling edge, and also the trigger. Let's move on to the trigger. You have here the trigger position. You can move it. As you can see, it's moving the trigger position. If you move on, you can change the rising or falling edge. And again, you have the auto, normal, or single. If you are in single mode and press run for a long press, okay, you will take another single run. Yeah, as you can see, it takes another single run every time. If you are, let me change this in auto, for example, and press run, it will stop so you can analyze the signal. And if you press run again, oops, with a long press, you will be able to put it running again. One last thing, if you press hold with a long press, you will take out the information from the screen, or again, to put it on the screen again. In the screen you have Vmax, Vmin, the average, the RMS, I think these are small letters, sorry if I failed something here, the VPP, frequency, duty cycle, yeah, the percentage of duty cycle, and this is the cycles, I don't know, time. Yeah, I think it is the time for each cycle. Okay, in terms of oscilloscope, that's it. Nothing too fancy, but it works great. So yeah, let's move on to the next function. And the next function is the function generator. Let's select it. Now I will disconnect this one, and I will have to connect this little guy. Okay, for the function generator, I went to grab my Mixig, connected here the alligator to MSX, to the DDS output, as you can see. And let's try to see how the signal is. We have the sine wave, square wave. Okay, so we have here the pulse. Let's change again the triangle. And what is this? The ramp. It seems pretty equal to the triangle, and also DC. Let's press auto. Yeah, so it seems to work pretty well. Let's try to increase the frequency. Like it's right now at 1 kilohertz, 2, 3. So yeah, take it to the maximum. That's yeah, and the maximum is 100 kilohertz. Okay, let's move this, and you can change also the amplitude of the signal. I thought initially that you cannot change the amplitude, but it seems that he allows you to change the amplitude of the signal. That is quite nice really. Not even there's 1104D desktop oscilloscope allow that, so this is a great improvement, Okay, it seems to work pretty well. There's not much here to talk about. Yeah, square wave, pulse. The square wave and the pulse, the difference is that in the pulse you can change the duty cycle. And triangle, ramp, yeah, also the same. So for this, I'm pretty glad with what they deliver as function generator. This is a great improvement over the PWM output that the TC2 had. So let's move to the next one. That should be tools. Yeah, let me just take this out of the way. Okay, so tools. In tools, what we have several functions. This one was not translated correctly. This is continuity. We have voltage measurement, the DSO-18B20. This is a temperature sensor, I think. This one is temperature and humidity, and here decode and calibrate. So let's start with the continuity. So continuity is pretty easy to test. Just connect here on 1 and 2, yeah, like this, and as you can see, it's like a multimeter. It will tell you the resistance. It's not giving you any values. It should give you here also some values. It's not giving, I don't know exactly why, but yeah. So the voltage is also another thing. I don't have anything right now to connect here, so I'm not even going to bother, but it will give you some values. You have also the temperature sensor. So I don't have here the temperature sensor. So, but I have one of these DHT11, I think. Let's put it on and see what happens. Yeah. So we have 26 degrees and 35% humidity. Seems to work pretty well. Only missing the infrared decoder. Let me grab some remotes. Okay, so in terms of protocol decoder, I have this one. It's from my TV box. This one, it will not initialize anything, but this from my LG television. If you press, as you can see, it will give you the code. Yeah, so you can debug everything, like up, sound down. Yeah, it will translate everything. In terms of IR, you can also, let me take you there, test it here on the component tester, just in this screen, and yeah, it will do exactly the same, but on another screen. So you don't have really to go to the tools option like this one to test the remote. But anyway, it's good to have it organized. Yeah, but it's exactly the same thing. So you can test the remotes in two places. What I'm going to show you now is how to access the setup menu. Anywhere in the system, you can press a long press in the menu key, and you will be able to access this menu. This is a pretty simple menu. You can select if the logo in the start appears or not. Also, what language are you using, Chinese or English, the volume of the bips, also the brightness of the screen. As you can see, it can change pretty easily. This is the factory defaults, and you have also the name of the devices and also the firmware version. So nothing much here. You cannot go to the site. It's just a menu to set up the device. Okay, the only thing that is missing right now is to show you how to do the calibration. For that, you grab the three hooks that are provided, connect to the 1, 2 and 3 positions. Well, you don't have to connect everything in the same place, but it will help. And shorten everything out. So connect this here and also this one. Everything is connected, and go to calibrate menu. He will detect that everything is connected right away. Wait for a moment. This is a very quick process, so you just need to wait a bit. Yeah, it's saying that please take this out of the way, and he detects that you removed the probes, and the process will end in a few seconds. And that's it. Pretty simple, huh? Okay, I just want to show you how you should do to compensate your probe. Just connect this alligator clip to DDS. Okay, using the adapter. Whoops. Connect it to your probe. Okay, and connect the probe to the DSO. You will have now here the compensation screw. Red with the claw, and black with black. Okay, this should be enough. So let's start the oscilloscope. Go to the signal generator. Okay, select the square wave. That's enough. Just go to oscilloscope, and okay, and now you have here the square wave. I'm gonna take the information out of the screen to help us see better. Okay, we have uncompensated probe. Let's try to put this in the right place. Okay, just rotate a bit. When the square wave, the corners are in 90 degrees, you should be okay. Yeah, something like this. Yeah, perfectly compensated. That's it. Let's move on. And also, that's how you will use the signal generator with the TC3 also. Just connect it to the alligator clips. Okay, moving on. Okay, so now it's teardown time. Okay, here we have it. Let me just disconnect the battery. We have here a 3.7 1500 milliamps hour battery. Okay, so let's zoom in and see what we have in here. Okay, so from the top we have here the three MSX connectors. We have also here the Cosmo 214S, that is a high voltage photo MOS relay. We also have, let me put this a little bit to the right so you can see it better. This relay, this one, the white, oops, the white one. This is a sub-miniature signal relay that withstands voltage to 2500 volts. Just below we have also the TL, let me see, 084C. This is a general purpose GFET quad operational amplifier. And just below we have this one, it's the CD4051BM. This is a single 8-channel analog multiplexer and demultiplexer. And below we have the ICL 7660, and this one is a CMOS voltage converter. Okay, this big one that is laser scrapped, I cannot tell you what it is. Probably ARM or one of those Chinese W something processors, but really it's scratch, so yeah, they don't want us to know what is going on there. We also have in here, let me show you this one. It's the COS 724. So this one, it's a 10 megahertz rail-to-rail input-output low-power operational amplifier. Okay, and in the bottom, I didn't show you this one. This is a switch. The TC2 didn't have this one. This should be probably to reset. I didn't saw the documentation yet, but I will check this out, and yeah, it is probably for reset or factory default. A lot of missed components, and in the end we have a very familiar one. This is the TC4056A. Basically this is a constant linear charger with also for lithium batteries and with protection. So this is quite used in this kind of devices. We see it a lot. We saw it also on the TC2. And basically that's it. We have some inductors, tantalum capacitors, and yeah, I don't see anything much special. We have here the board revision, TC3 version 2. Those are probably some GTEC connectors or something like that. Yeah, I don't know. Okay, I think that's it. Let's wrap this up now, and I will start by sharing my personal opinion on this device, starting first with the price. It is being sold on AliExpress FNIRSI store for 47 euros or around $50, and that is 3 to 4 euros more than the price of launch of the DSO-TC2 in June of 2022, so more or less 9 months ago. Considering the inflation in the world and everything is going on around us, I believe that's an increase of more 10% that unfortunately is in line with the reality we live those days. But if you consider that you will have a device with a lot of improvements, now has a signal generator also, I still think this is a great buy. For professional, this is a great component testers, and since you are a professional, you probably have a better oscilloscope already. But as a component tester, this is really good. For students or hobbyists, or even professionals with low requirements on oscilloscopes, this will be a great 3-in-1. You will have a 500 kHz oscilloscope with a sampling rate of 10 megasamples per second and a function generator with 6 different waveforms. And I'm not even counting with the other tools that are provided, like the infrared code reader or the temp sensor reading. For me, this was a no-brainer when it was released last year. And with the corrections like the SR on the capacitor testing and the addition of a signal generator is even an easier decision. So, if you are on the market for a tool like this, please remember that you have the affiliate link to buy this device on the description, and you can also use the affiliate access links here on the screen. Again, thank you for your help. It's really appreciated. And if you learned something and this video was in any way useful to you, please smack that like button, and if you haven't already, please subscribe and hit that bell to activate the notifications and be one of the first to be notified whenever I upload a new video. That's it for today. I really appreciate your company and I hope to see you in my next video. Until then, stay safe. Cheers!